This lecture is about differential equation. What is differential equation? Differential equation is a mathematical equation that relates an unknown function to its derivatives. It involves one or more derivatives of an unknown functions with respect to one or more independent variables. Differential equations are widely used in various fields of science, engineering, and mathematics to model and analyze dynamic systems and phenomena. Throughout the video, we will see the notations, the form of differential equations, and how we solve the differential equation problems. So stay tuned and check it out. The notation of differential equation can be formed in the form of dy dx equals to the function of variable x and y. It can be a single variable, x only, or it can be both in x and y variables. The form of differential equation. We have three forms of simple differential equations. The first one is dy dx equals to a function of x. The first form is very familiar for us since we already learned about the differentiation and integrations. We already learned this before. That's the first one. And the second one is dy dx equals to fx. In this form, we can see that there are two functions in terms of y and in terms of x. And the last form is gy dy dx equals to a constant. Let's see one by one. Let us see the first form. The first form is the form of dy dx equals to fx. The dy dx equals to fx has general solution of y equals to integral of fx dx. We can see the example. If we have dy dx equals to 3x squared plus 4x minus 4, which is this is a function of x. How do we find the y? We can just use the integration. Integration of 3x squared plus 4x minus 4 dx. And the result is x cubed plus 2x squared minus 4x plus c. The second example, dy dx is equals to x squared e for x. And to find the solution, we need to integral x squared e for x cubed dx. To integrate this, we will use the substitution method. Yeah, we let u equals to 4x cubed. So du equals to 12 x squared dx. And dx equals to du over 12 x squared. And then we can change into integral x squared e to the power of u du over 12 x squared. Yeah, we use this to change the dx here. And then it can be simplified equals to integral eu, and we have x squared over 12x squared du. We can cross the x squared. So we have 1 over 12 integral e u du. And the integration of e exponential to the power of u is exponential to the power of u. Stay the same. Plus c. So 1 over 12 e to the power of, we replace back for x cubed plus c. So we can see the solution of the differential equation is equals to 1 over 12 e to the power of 4x cubed plus c. That's the first form. The first form is very simple because we did this during the integration. Next, the second form is in the form of gy dy dx equals to fx. If we see from the form, we can see that the function of y is separated from the function of fx. So in here, we have a method called separating variables method. So for example, dy dx equals to xy. If we see here, the x and y are combined in one side. By separating variable methods, we can separate the variables. So we can move the y to the left side. We have to change this form into the form of the function of y times dy dx equals to the function of x. So we can change this into 1 over y dy dx equals to x. So we can have y dy dx and fx here. Yeah, this is the gy and this is the fx. Now, how do we solve it now? I rewrite again, 1 over y dy dx equals to x. To solve this differential equation, we can integrate both sides with respect to variable x. So we can cross the x here, and it simplifies into 1 over y dy equals to integral of x dx. Now we can integrate it easily. Integral 1 over y dy is equals to ln y plus c, and integral x dx is half x squared plus c. Since c in the left side and in the right side is different, so we can make this one as c1 and this is c2. So we can rearrange ln y equals to half x squared plus c2 minus c1. Since we don't know the c2 and c1, so we can combine the c2 and c1 into another variable c. So it's ln y equals to half x squared plus c. Now, the equation doesn't stop here. We have to express in the terms of y equals to. We have to make y as the subject. To make y as the subject, we have to remove the ln here. So we can use the exponential e to the power of ln y equals to e to the power of half x squared plus c. E to the power of ln y is y, and e to the power of half x squared plus c we can rewrite as e to the power of half x squared times e to the power of c. C is an arbitrary constant. E to the power of constant is another constant. So I can just write this as a. So e half x squared times a. So it can simplify into a e half x squared. This is the general solution. Why do we call it general solution? Because we don't know the value of a. The constant a will be found using additional informations. But this is how do we find the general solution. That's the first one. Let's see another example. Example number 2. The dy dx is equals to y over x. The same method. First, we have to do the separating variable. We can move the y to the left side. So it's become 1 over y dy over dx equals to 1 over x. And then after that, we can integrate both sides with respect to dx. Integrate both sides respect to dx. So it simplifies 1 over y dy integral 1 over x dx. The left hand side equals to ln y plus c1, and the right hand side is equals to ln x plus c2. Again, c1 and c2 can be collected into c2 minus c1. We can change again into the variable a, for example. So ln y equals to ln x plus a. Now, how do we make y as the subject? If we see both sides contain ln, if we want to use the property of ln, so we have to change the form a in the form of ln. So we can change a into ln k. A is a constant, so I can express this as another constant, which is ln k. Ln k is another constant. It doesn't change the meaning. So ln y equals to ln x plus ln k. Ln plus ln, using the rule of logarithm, ln a plus ln b equals to ln ab. Using this rule, so we can combine ln y equals to ln x times k. Simplifies ln kx. And then we can ignore the ln. So y equals to kx. This is the general solution. So in this case, we can see there are two types of method to solve the equations. The third example. Example number 3. dy dx equals to x y squared plus 3y. The same method, we have to separate the variable. We can move the y to the left side. It becomes 1 over y squared plus 3y dy dx equals to x. That's the first step. Second step, we can integrate both sides with respect to dx. It simplifies into 1 over y squared plus 3y dy integral x dx. Okay, the right part is easy. It's equals to half x squared plus c. How about the left part? How to integrate 1 over y squared plus 3y dy? We can change the form of the denominator into factorize the denominator y plus 3. We can ask help from partial fractions. 1 over y plus 3 can be split into a over y plus b over y plus 3. Don't forget this is partial fraction. So we can simplify a y plus 3 plus by y plus 3. So this is the same thing. The denominator already the same. So I can just make y equals to a y plus 3 plus by. If y equals to 0, 1 equals to 3a. So a equals to 1 over 3. If y equals to negative 3, 1 equals to 0 minus 3b. So b equals to negative 1 over 3. So that means the partial fractions form 1 over y plus 3 is equals to a over y. So 1 over 3 over y plus negative 1 over 3 over y plus 3. Or it can be simplified 1 over 3, 1 over y minus 1 over y plus 3. Now, this value now can be taken into our equation. So we can rewrite as, maybe I can copy, duplicate, and then I will move it down here. So I can rewrite as integral 1 over 3, 1 over y minus 1 over y plus 3 dy equals to 1 over 2 x squared plus c. I can put out the 1 over 3, 1 over y minus 1 over y plus 3 dy. To make it simple, I can just multiply by 3. 3 over 2 x squared plus c. Yeah, 3c and c the same because c is the arbitrary constant. Yeah, if you put 3c, the 3c can be written as c. So it's okay. Just make it another c. So solve the left-hand side, become ln y minus ln y plus 3 equals to 3 over 2 x squared plus c. And don't forget, we have c1 here. So we can move it to the right. Yeah, c minus c1. And this will become another c, another constant, arbitrary constant. So we can just write as minus ln y plus 3 equals to 3 over 2x squared plus another c. Yeah. Again, we have to express as a y as the subject. So we have to combine the y. Ln minus ln, according to the same rule, is ln. Okay, what's the rule? Ln a minus ln b equals to ln a over b. So ln y over y plus 3 equals to 3 over 2x squared plus c. And then, so we have to remove the ln. So it's become y over y plus 3 equals to e to the power of 3 over 2x squared plus c. If we notice, the right part has the same form as the previous question. Question number 1. See? So we can express this as a. So equals to e 3 over 2x squared times a. y plus 3. And then make y as the subject. So we can cross multiply. So y equals to y a e 3 over 2x squared plus 3a e 3 over 2x squared. And then we collect the y minus y a e 3 over 2x squared equals to 3a e 3 over 2x squared. We can factorize 1 minus a e 3 over 2x squared equals to 3a e 3 over 2x squared. So y equals to 3a e 3 over 2x squared over 1 minus a e 3 over 2x squared. You can stop until here, but it will be better if you can change the form. Yeah, by multiply both sides, both numerator and denominator by e negative 3 over 2x squared over e negative 3 over 2x squared. So we can have 3a e to the power of 3 over 2x squared times e negative 3 over 2x squared is equals to 1 over, okay, I just write e 3 over 2x squared times e negative 3 over 2x squared. And then the bottom one is e negative 3 over 2x squared minus a e 3 over 2x squared e negative 3 over 2x squared. So this is equals to 1, and this as well equals to 1. So we have 3a over e minus 3 over 2x squared minus a. This is the final answer. So after 3 examples, we can draw a summary. There are 4 steps to find the solution of the type number 2. Yeah, these 3 examples are the example of differential equation type number 2. The first step is we have to do the separating variable. Move y to the left side, yeah. And then after we do separating variable, we can integrate both sides with respect to x, or we call it the x. After that, we can integrate normally, yeah, using the suitable methods. We can integrate them normally as usual. And then the last one, simplify and make y as the subject. These 4 steps will be used in the type 2 and type 3 of differential equation problems later on. The third form is dy dx equals to a constant. The method to solve this form is the same with the method on the previous form, but this is simpler. We can see the example number 1. Dy dx is equals to y. As you can see in here, the differential equation is only contain the function of y. There is no x in here. So using the separating variable, we can move the y to the left-hand side, become 1 over y dy dx equals to 1. Yeah, so this is the third form. The function of y dy dx equals to constant. And then we can just use the integral both sides with respect to x. So it simplifies 1 over a on 1 over y dy equals to integral dx. The left side is ln y, and the right side is x plus c. C here is the combination of C2 minus C1, yeah? So we can just ignore the C1, C2, or any other constant. We just call it constant C. How do you remove the ln here? Make the y as a subject. So y equals to e to the power of x plus c, and this leads us to e x and then times a. Yeah, so this is the answer, the general solution. Example number 2. dy dx equals to e to the power of negative 2y. Using the separating variable, we can make it 1 over e minus 2y dy dx equals to 1. Or we can rewrite as e 2y dy dx equals to 1. And then we integrate both sides with respect to x. It becomes e to y dy equals to x plus c. The integration of e to the power of 2y is 1 over 2 e to y equals to x plus c. So e to y equals to 2x plus c. So we can just leave the answer in form of this. Yeah, because make it y as the subject from this expression. It's not change the form into a simple version. So we can leave it here. Here are some exercise. I will discuss this in the other video. And then the last part is finding the constant of the general solution. All of our answers are the general solution to the differential equation because it contains the constant a, constant k, constant c. Now, how do you find the constants? We need additional information. Let's see the example. Find the solution to the differential equation y dy dx equals to y plus 1 squared. Given that when y equals to 0, the conditions is y equals to 0, x equals to 2. Give your answer in the form of y equals to fx. As we know that this form is similar to the form number 3. So we can just move the y here to the left side. It becomes 1 over y plus 1 squared dy dx equals to 1. And then integrate both sides with respect to x leads us to integral 1 over y plus 1 squared dy equals to integral dx. So this is equals to negative 1 over y plus 1 equals to x plus c. We can find the value of c using the condition when y equals to 0, x equals to 2. So we can put the condition here, negative 1 over y equals to 0, x equals to 2. So negative 1 equals to 2 plus c. So c equals to negative 3. So the expression is y plus 1, x minus 3. And then don't stop until here because the question asks you to express your answer in the form of y equals to fx. So we have to change the form. So it's negative 1 over x minus 3. I do cross multiply equals to y plus 1. So y equals to negative 1 over x minus 3. So this is the final answer. As you see here, there is no more unknown constant like C, A, or K, or anything else. For all the exercise, it will be in different video. So that's all for this topic about differential equation. The summary that we can take here is this. There are 4 steps in solving the differential equations. First, we separate the variables, put the y on the left side and x on the right side. And then we integrate both sides with respect to variable x. And then we can integrate both sides normally using the conditions. And the last step is simplifying the expressions. That's all.